Hello and welcome to Chapter 18. The main point of this is to create review and coordination processes to increase quality of our current work. First thing we want to talk about is what is GitHub? GitHub is a platform that is used for collaboration and version control, usually with code. However, it can contain any kind of file, such as HTML, CSS, JavaScript, PNGs, PDFs, etc. Usually there is a main branch. Well, always there is a main branch. New branches are made as copies where you can do additional work and then merge it back in. Some of the basics of GitHub are that your changes are called commits. Each commit is accompanied by a description explaining what the change is. A pull request lets everyone know that a merge is being proposed. It shows all the differences between the branch that you've created and the master branch. The merge will make any changes official to the master branch. The flow for DevOps when using GitHub is something like the following. An engineer creates a descriptively named branch. They commit to the branch locally, regularly pushing their own work to it. They then get feedback or help, have it reviewed, and then they can open a pull request. After the pull request is open, they get more reviews, if necessary, approvals. And then once it's approved, the engineer can merge it into the master branch. Once it's merged, it can then be deployed into production. However, there are some dangers of the change approval process. A low trust or command and control environment can often result in blame and shame. There could be an accident when something's being reviewed, there could be a mistake. And these both usually end up with more approval steps being added, more testing, which honestly can make it easier for the problem to happen again. One of the dangers of overly controlling changes is that it can create longer lead time. It adds more questions that need to be fulfilled for the change request form. It requires more authorization from managers, which means more time. As the challenges increase, so do the batch sizes and deployment time. It decreases the likelihood of a successful release. However, we can try and make changes a little smoother. In rigid architecture, we can schedule what time changes are going to be made. In a looser structured environment, we need to keep in contact. There's a lot of high volume changes. And so we need to be able to tell everyone, hey, I'm making this change now. For larger changes, such as when you're dealing with a global infrastructure, we have to make sure that in case something goes wrong, there's a countermeasure in place. Redundancy, failovers, comprehensive testing, and simulation. In general, we need to make sure that we're not going to crash the whole system anytime we make a change. One of the ways we can do this is code reviews. We can get other people in our own department, our own managers, to review our code without having to go outside of the department. It can help find errors, it can help train new people, it promotes learning, and it can improve skills. In general, it's just a really good idea. However, we need to remember that large groups of code can be hard for people. It's going to take longer to look at, and problems can be overlooked. So, if possible, we want to do smaller batches of code to be reviewed. It's more efficient, it allows it to be reviewed faster and with ease. And if it's something needs changed, it's a lot easier to change one or two things in a few lines of code than in 10,000. And everyone has to be reviewed. It's not just one engineer. Everyone should be looking out for conflicts, making sure that it's not going to damage something that's already in place. Um, and if it's too big, break it up. It's okay if it takes more than one change. The different types of review are pair programming, where from the beginning you work in a team and you check each other as you go along. Over the shoulder reviewing allows the author to walk through the code while someone else watches and checks. This can be great for people who are less familiar with the code. It allows the author to show them how it works while they can still keep an eye on did you dot your I's and cross your T's. Email pass around. When the code is submitted and checked in, it automatically gets sent in an email to someone who can review it. Tool assisted code review. Some platforms, such as GitHub, Garrett, Atlassian, Stash, these have tools that are made to review code. And so, if you're working on your own or working in a small enough group that someone might not have time to check your code, you can run tools like that. Earlier, we talked about pull requests, and there's a good kind of pull request and a bad kind of pull request. Bad pull requests are, such as listed on the right side, change number 17. That doesn't tell you anything about what the change is. If there's an error, it doesn't tell you where it went wrong. On the left side of the screen, a good pull request, change number 17 made by Peter Spat fixed the issue of pulling extraneous data when only making a single query. See code line 127 for change. This allows you to know who changed it, why it was changed, and where it was changed. If something goes wrong, we know where to check. We know who to talk to and be like, hey, what was it before? It puts reliability into the code and it makes it a lot easier when working with teams. And finally, some potential dangers of manual testing. When testing fails, we have a tendency to test more. However, if we only test at the end of a project, we can get some pretty bad results. And this happens the most with manual testing, which is slower and more tedious. So, our goal to prevent these issues is to integrate testing into our daily work instead of just at the end. Our hope is that this will be smooth and continual into production, and we can increase our deployment frequency. Our ultimate goal is to get this code, this product out to our consumers, and we want to make it as best as we can. Thank you guys for listening. Here are our resources, and I hope you like our presentation of Chapter 18.